What does it mean when someone says a 32-bit operating system or a 64-bit CPU? Well, it's not an easy topic to explain if you're not a software programmer or an engineer, but I'm going to try to explain what is meant by the bitedness of a CPU and the bitedness of an operating system in this tutorial. So we'll start our first section of our tutorial by talking about memory. Now, memory is this big thing here that stores basically a lot of numbers, a lot of binary numbers. So we're going to have a memory system in here, and our memory system is going to store 4 numbers. The numbers don't need to be, numbers are all the same size. They don't need to be small. It can be very large numbers. But if we have a CPU here, a CPU basically uses memory for instructions, holding things which are called data, which are called instructions. But to actually access different numbers, there needs to be a mechanism to do this. Now, we're going to talk in the CPU about this thing called a register. A register is just something that stores bits of information inside a CPU. So it's sort of like a little memory location. Now we're going to talk about a register that can store 2 bits. So it's called a 2-bit register. And this register will be used to access our memory, because each memory, this is the data that's in the memory, but each memory has what's called a location or an address. So I'm going to give a label to all these memory locations here. The register is used to determine which of these locations the CPU is going to access. So the CPU basically uses this register, and so if it puts 10 here, the CPU is accessing, it can either write to or read from this location. So the size of registers inside CPU can determine how much memory I can actually access. If we look at this example here, I can only access 4 locations of memory. So if I've got a memory system that's got 7 locations, I can't access it because I'm only using a 2-bit register. How many locations I can actually access is given by a formula 2 to the n, where n is the number of bits I have here. So 2 to the 2 is 4. If I have an 8-bit register, then 8 bits can access 256 locations, and so on. One of the first Intel CPUs was an 8086, and it was called a 16-bit CPU because internally its registers were 16 bits long. However, the 8086 added another 4 bits onto that. So it had, for accessing memory, it had a register that was 20 bits long. So 2 to the 20 gave us 1 megabyte memory limit. So that's where the memory limits of CPUs come from. Often it comes from the registers. So we've talked a little bit about memory. We're going to next talk about instruction set. What is meant by an instruction set? Inside every CPU there are a bunch of instructions. You can think of this as the vocabulary of what the CPU can do. So it can add, it can decrement, which means subtract 1 from a number. It can loop, it can do what are called conditional tests, and each of these instructions have a certain code. So I might have a code for adding 2 numbers as a binary code like that using 4 bits. For decrement, it might be a different code. For looping, if some register was 0, maybe a different code yet again. All these instructions are 4-bit codes, and I could even have combinations. Some instructions may be longer than just 4 bits. If I'm adding a number, I may want to put the number alongside it. So my whole instruction might be add, but then I might have a 4-bit number for the numbers that I want to add. So this is the number 9. So this might be add 9 to something. So some instructions could be double what are called words. This is the word length, which is what a CPU sort of naturally processes bits in, to sort of the size of the chunk. So we could call this all the instructions that the CPU can understand. We could call this the 4-bit instruction set, if most of the instructions were 4 bits long. Now, if we go back to our original CPUs and we look at an 8086, an 8086 internally had 16-bit registers, and most of the instructions were some code of 16 bits. So its instruction set was called a 16-bit instruction set. Now there were other 16-bit CPUs at this time, Motorola, and this was an Intel processor here. Motorola had a 68000, and it also had 16-bit instructions. However, it used different codes. Instead of add, it may have had some extra instructions here. It used a different coding system. So it also had a 16-bit instruction set, but I'll use a different color here. But its set used totally different codes. So if you had software that was written using the Intel instruction set, it could not be understood by a 68000 CPU. It's almost like two languages. Like you could think of this being English and this being French, and each CPU is unilingual. So something that is in French cannot be understood by the English CPU, and vice versa. Well, how does this pertain to various CPUs which are on the market? So we're going to look at a bunch of different CPUs. We've talked about the 8086 from Intel. It had a 16-bit instruction set. When the 386 came out, it was also from Intel. So the 386 inside was one of the first Intel CPUs to have 32-bit instructions, 32-bit registers rather. And inside it, it supported, that meant it understood the 16-bit instructions from the previous 8086. This gave it backward compatibility, so it had the ability to understand the 16-bit Intel instruction set. But it also had a brand new instruction set that was more powerful and that ran a little faster, called the 32-bit instruction set. And so together, this was the instruction set capability of the 386 and later the Pentiums. Now this architecture had a certain name which I'll actually use now. It was called IA32. Now Motorola, with its Power PCs, also had a 32-bit instruction set. However, as I've used in the previous example, used totally different codes. So something written for a PowerPC was just like a different language than the Intel 32-bit instruction set. So applications on the PowerPC could not run on an Intel 32-bit instruction, even though they're both 32-bit CPUs. Now, as an evolution of CPUs, Intel decided that the 386 architecture, which later became the Pentium is also a 32-bit CPU. For servers, Intel decided to totally redesign their CPU, and they called it the Itanium. And they thought the Itanium was going to become their next greatest CPU, and it was designed for servers and high-end workstations. And it started by having 64-bit registers and a whole new instruction set, which they called a 64-bit instruction set, or Itanium instruction set. Now, the problem with the Itanium was that the Itanium instruction set was not compatible with the 32-bit instruction set here, and therefore if you wanted an operating system or applications for the Itanium, you had to write them from scratch. Nothing was backward compatible. Well, a lot of problems existed from getting people to adopt the 64-bit instruction set. So one of the things that Intel did was they added a device here which could interpret the 32-bit instruction set of the older Intel CPU. So if you had a 32-bit instruction or program, you could put it through this device. Really, it's like a translator, and it would translate it to 64-bit Itanium instructions, and then it could be executed by the CPU. This is called an emulator. Really, it's a translator. It was done in hardware, but still, that made it slow doing this translation. So, what else happened in this? What else happened in this market? Oops. Try to get rid of some of this stuff. Maybe we will, and maybe we won't. Well, around this time when this was happening, AMD was producing really good CPUs, especially the Athlon, and they decided, because the Athlon was in a different physical hardware than the Pentiums, they had the ability to add some more pins and add some more hardware. So inside the Athlon, they added a few registers that were 64-bit. The big problem at this time for servers was that if you looked at the 32-bit Pentium system, it could access, the registers were 32 bits long, and it could access memory. How much memory? Well, 2 to the 32, which is 4 gigabytes of memory. And it was starting to happen that in servers, 4 gigabytes was a limit that needed to be overcome for better performance. AMD saw this, and so what they did was they supported the 32-bit instruction set, because AMD CPUs were really functional clones of Intel. You could their selling feature was that you could use an AMD CPU and you could still use all your same software that you were running on your Intel boxes. So they supported the 32-bit instruction set, but they enhanced it. And they added some extra instructions in here that allowed more memory to be addressed. So these are extra instructions which you can use to access more than 4 gigabytes of RAM. And so one of the first CPUs that they had this in was called the Athlon 64. And people adopted this because they could use a lot of their own software, but they could easily access memory beyond 4 gigabytes. And this was so popular that Microsoft actually started to design versions of their operating system just to this standard. Well, this became so popular that Intel eventually changed their Pentiums to support the standard. And the standard was being called a 64-bit standard. So AMD was saying, hey, these are 64-bit CPUs, but really they were quasi 32-bit CPUs that were modified slightly to access more memory. Intel was calling it Titanium 64-bit, so there was confusion in the marketplace about what really was a 64-bit CPU. The PowerPC, Motorola, actually IBM came out with a version of the PowerPC that was 64-bit called the G5. All of these were different. That is, the G5 from IBM had its own instruction set which is not compatible to the Itanium, and the Itanium is different yet than Intel's architecture. So this new standard, some called the AMD 64 standard, was adopted by Intel, and Intel gave a designation to their Pentium CPUs called EM64T. And if you got a Pentium, now all new Pentiums and processors that are called Core 2 Duos, or they go by various names, they're all today compatible with this 64-bit standard. Okay, so what does this all mean? Well, as far as operating systems go, the IA64 stands for Intel Architecture 64, and this means the Itanium processor. So if you have an operating system that's Itanium compatible, Windows has versions of its server that are Itanium compatible. They had versions of XP, but you need that designation of Itanium to run on for the operating system to run on this platform. So IA64 is a 64-bit Itanium version of an operating system. IA32 is the Intel Architecture 32, and its original instruction set is called the x86. So we have many versions of Windows, and if you have a version of Windows that's x86, it means it's running a 32-bit version of Windows. It's using the 32-bit instruction set inside Pentium CPUs. Now, all CPUs today are capable of running this x64, this enhanced 32-bit operating system. That is, today's CPUs from Intel all support the 32-bit instruction set plus the 64-bit extensions that allow it to access more RAM than 4 gigabytes. Well, Microsoft came out with versions of Windows that were specifically written using these 64-bit extensions, and they designated those versions of Windows as x64. Sometimes you'll see it designated as x86-64 because really it's just an extension to the x86 instruction set. Now the problem here becomes when you have a 64-bit. If you're running Windows that's running 64-bit, all your drivers have to also be 64-bit drivers. Your applications, they can be 32-bit. So you could, if you have installed a 32-bit version of Windows 7, you can often run your 32-bit applications. But if you've got a printer, the printer needs a 64-bit driver, and sometimes you can't find those. So when the 64-bit versions of operating system of Windows first came out with Windows XP, most people switched, but then they realized they couldn't get the drivers and third-party companies wouldn't support it. So that was often a real issue. And even today, Microsoft produces Windows still with 32-bit versions and 64-bit versions. On their server platform, starting with Server 2008 R2, which is a Windows 7 core, they have stopped supporting 32-bit versions. There's only a 64-bit version of that. But on the client side, even in Windows 8, there are still 32-bit versions and 64-bit versions. If you have or want to use more than 4 gigabytes of RAM, you need to make sure you install the 64-bit version of the operating system, but then you need to make sure all your drivers are 64-bit. In the OS X side, they've made it a little easier. The OS X side had 2 CPUs that they were supporting. So this was a little more different. They had a PowerPC. And then around the Lion operating system, they started to turn over all their computers to use an Intel CPU. And it was mostly because the PowerPC couldn't run as fast and couldn't run as cool, and Intel had a more efficient CPU. So their original operating system ran on PowerPC. Their new operating systems run on Intel, and part of the problem were that apps had to be written for one or the other CPUs. So if you had a PowerPC application, initially you had to run it through an emulator if you were running on an Intel processor. So around the time of Leopard, the emulator was called Rosetta, and it allowed Apple to run its new operating system on an Intel CPU, but it provided backward compatibility with older PowerPC applications. In today's operating system, Mountain Lion, Rosetta is no longer used, and all apps have to be written in native Intel instruction set. Now, what about the 32/64-bit problem? Well, the core of a OS X operating system is called a kernel, and the kernel could run in 2 modes. It could run in a 32-bit mode or a 64-bit mode. So Apple really hid this whole 32 or 64-bit from the user. It had what were called kernel extensions, which were like drivers, which surround here, and they could be 32-bit or 64, but for most part, the 32 and the 64-bit is hidden from the user. In previous versions of OS X, the kernel ran in what was called 32-bit mode, but starting in Mountain Lion, the kernel's written in a full 64-bit for 64-bit mode, and gives you access to virtually as much RAM as the hardware will support. So a lot of different concepts here. The IA32 was the original Intel architecture, which had a 32-bit instruction set called the x64. AMD expanded that because AMD wanted to access more RAM, and that became very popular. They started to outsell, in some ways, the Intel processors because of this capability. And they called this instruction set x64, but it's really an enhancement of this one. However, it is generally called the 64-bit version of an operating system. Intel very quickly added this capability to all their CPUs, so all the Pentium CPUs that are out today have this capability as well. The IA64, though, is really a totally new architecture. It's based on what's called the Itanium. The Itanium hasn't gotten widespread application, but it's still an available CPU to build a server platform on. OS 10, when it started, the CPU platform was called the PowerPC, which started coming out as a 32-bit operating system, evolved to a 64-bit operating system. However, Apple switched from that to the Intel CPUs, so it really is using this sort of enhanced 64-bit architecture to run all its operating system software on. With Mountain Lion, it's running its kernel in a 64-bit mode, but most of the ideas or concepts of a 32-bit application or 64-bit application are hidden from the user.